Imagine a world where the air in our busiest cities is as fresh as a mountain breeze. Picture a vehicle that glides silently down the road, its only emission a gentle puff of clean water vapor. This is not science fiction. It is the profound promise of hydrogen, a fuel that could fundamentally change our relationship with energy and the planet. For decades, we have relied on fuels that darken our skies and warm our world. The idea of a car that leaves behind only water feels like a dream, a whisper of a cleaner future. It is a powerful vision, one that offers a glimmer of hope in the face of our greatest environmental challenges. This vision is powered by the most abundant element in the universe. Hydrogen holds the potential to power our lives without polluting our home. It offers a way to move our heaviest vehicles, trucks, To understand this potential, we must first understand hydrogen itself. It is the simplest element, the first on the periodic table. Each atom of hydrogen consists of just one proton and one electron. It is incredibly light, a gas that is all around us, but rarely found on its own. Instead, it is most often bonded with other elements. The most famous of these partnerships is with oxygen. It is also a key component of the fossil fuels we currently depend on. It is an energy carrier. This means we must use energy to produce it, and it then stores that energy until we are ready to use it. Think of it like a rechargeable battery. Similarly, we use energy to separate hydrogen from water. The process of unlocking hydrogen from water is particularly elegant. It is called electrolysis. There are two primary methods for harnessing the energy stored within hydrogen to power a vehicle. The first, and perhaps the most elegant, is through a device known as a fuel cell. A fuel cell is like a power station in miniature. It does not burn the hydrogen. Instead, it facilitates a quiet chemical reaction. Inside the fuel cell, hydrogen gas is passed over a special membrane. This membrane separates the hydrogen atoms into their protons and electrons, creating an electrical current that powers the vehicle's motor. They then combine with oxygen drawn from the surrounding air. The result of this beautiful controlled reaction is electricity, heat, and pure water. This is why vehicles powered by fuel cells, known as FCEVs, are considered zero-emission vehicles, but with the convenience of refueling in minutes, much like a conventional petrol car. The second method is more familiar. It involves burning hydrogen in an internal combustion engine, much like the engines that have powered our cars for a century. The hydrogen dream is not confined to laboratories and research papers. It's already on our roads, in the hands of pioneering automakers and forward-thinking cities. Toyota, for example, has been a long-time advocate for this technology. Mirai, a sophisticated second-generation fuel cell sedan, over 400 miles of range refueled in about 5 minutes, convenience comparable to gasoline. Hyundai's Nexo SUV, practical and advanced, a rolling air purifier, filters fine dust and particulates as it drives. Honda, Honda Sturm, Andens, Dorn, Nodadjern. Other early pioneer, cities around the world are deploying hydrogen buses. London. Let us take a moment to imagine what a worldwide switch to hydrogen might look like. In this future, the air in our sprawling metropolises would be noticeably cleaner. The persistent haze of smog that shrouds many cities would dissipate, revealing clearer skies and healthier environments. The noise of the city would also change. The constant rumble and roar of diesel trucks and buses would be replaced by the quiet hum of electric motors powered by fuel cells, creating a more peaceful urban landscape. This transition would reshape the global energy map. Nations blessed with abundant sunshine, strong winds, geothermal resources could become the energy powerhouses of the future. Australia, for instance, with its vast, sunny deserts, could become a massive exporter of green hydrogen to energy-hungry nations in Asia. This shift would create new geopolitical dynamics, a global network of pipelines, liquefaction plants, Despite this inspiring vision, the path to a hydrogen-powered world is fraught with significant challenges. The most immediate hurdle is cost. Today, producing green hydrogen is considerably more expensive than producing gray hydrogen from natural gas. The second major obstacle is infrastructure, or the lack thereof, concentrated in small clusters in places like California and Japan. The round-trip efficiency of the hydrogen pathway is lower than simply charging a battery and using that electricity directly. For a small passenger car used for city driving, a battery electric vehicle is often a more efficient and direct use of renewable electricity, but specifically for those where batteries are impractical. To store enough of it on board a vehicle to provide adequate range, it must be either compressed to extremely high pressures or cryogenically cooled into a liquid. For hydrogen to fulfill its promise, we must relentlessly focus on reducing the cost of green hydrogen to create an abundance of cheap, clean electricity. Cheaper electrolyzers, more durable electrolyzers. The most likely future is a balanced one.